Today we discuss about fabric manufacturing process. Textile fabric may be defined as the flexible assembly of fibers or yarns, either natural or man-made. It may be produced by a number of techniques, the most common of which are weaving, knitting, bonding, felting or tufting. Conventional fabrics, woven, knitted, are produced in such a way that the fibers are first converted into yarn and subsequently this yarn is converted into fabric. The fabrics can also be produced directly from the fibers. Such fabrics are termed as non-wovens. The weaving process. Woven cloth is normally much longer in one direction than the other. The lengthwise threads are called the warp, and the other threads, which are combined with the warp and lie widthwise, are called the weft. Synonyms are filling, woof, and shoot, or shoot. An individual thread from the warp, of indefinite length, is called an end. Each individual length of weft, extending from one edge of the cloth to the other, is called a pick, or shot. Consecutive picks are usually consecutive lengths of one piece of weft yarn that is repeatedly folded back on itself. Processing of woven fabric. Weaving process consists of following process. 1. Winding. 2. Warping. 3. Sizing. 4. Drawing in. 5. Weaving. Winding. Winding consists in winding the yarn on a tube. The weaving cones are prepared for the warp, vertical threads, in a cylindrical form, all of the exact same length to avoid waste. For the warp to be produced, conical bobbins are made so that the yarn can slide on the frame without problems. Sometimes the bobbins are wound before dyeing in the form of a ball to allow that the dye colorant can penetrate evenly throughout the yarn. Warping process. We know that woven fabric is made by two sets of yarn, warp and weft. Warp yarns run with along the length of fabric and weft yarns go across the width of the fabric. Warping is the preparation of yarn to weave fabric. It is the transfer of many yarns from the creel of single packages to a beam. The yarns will form a parallel sheet of yarn wound onto the beam. The basic objective of warping is to build a package where yarn ends remain in uniformly set parallel and continuous form and thereby to accelerate. Sizing. Sizing serves to strengthen the fine single yarns for weaving. Yarns are categorized into single and two-fold. The two-fold yarns are those composed of two or more threads twisted together, while single yarns are very delicate and difficult to weave. The warp threads are immersed in a bath containing the sizing agent which stiffens them. The yarns, once released from the drying room, are individually separated by large bars, not to create problems during weaving. Drawing in. In order to create fabrics with different structures, e.g. Oxford, poplin, each thread has to move in a precise order. For this reason it is placed in the slats of the warp stop, and drawn in thread by thread through the eyes of the heddle and through the teeth of the reed. If a loom will weave successive fabrics with the same structure, the drawing in stage can be skipped and each thread tied to the corresponding warp thread that is ending directly in the loom. Thanks to modern technology, it is possible to draw in up to 200 threads per minute through the heddles, reed, and comb in one pass. Despite the highly automated process. Weaving. When the weft yarn meets the warp, a fabric is created. Synthesis of the raw material and the creativity of the design and structure. The weaving is made on highly technological weaving looms through a complex process carried out with the utmost care, in a controlled environment, and with great experience of the weaving staff. The looms can produce the simplest fabrics with 640 passes per minute, but proceed much more slowly to weave the finest and most delicate fabrics. The unfinished fabric at this stage is called grige. Shuttle loom. The shuttle loom is the oldest type of weaving loom which uses a shuttle which contains a bobbin of filling yarn that appears through a hole situated in the side. The shuttle is batted across the loom and during this process, although very effective and versatile, the shuttle looms are slow and noisy. Also, the shuttle sometimes leads to abrasion on the warp yarns and at other times causes thread breaks. Shuttle-less loom. Many kinds of shuttle-less looms are used for weaving such as projectile looms, rapier looms, water jet looms, and air jet looms. Projectile loom. A weaving machine in which the weft thread is gripped by jaws fitted in a projectile, which is then propelled through the shed. It has a small hook-like device that grips the end of the filling yarn. It is sometimes called missile loom as the picking action is done by a series of small bullet-like projectiles which hold. Rapier loom. Rapier looms are machines in which the means of carrying the weft through the shed is fixed at the end of a rigid rod or in a flexible ribbon, this being positively driven. A rapier machine may have a single rapier to carry the weft across the full width, or a single rapier operating bilaterally with a centrally located bilateral weft supply, or two rapiers operating opposite sides of the machines. Rapier loom comes in many types. Early models of it use one long rapier device that travels along the width of the loom to carry the weft from one side to the other. Another type of rapier loom has two rapiers, one on each side of the loom. They may be rigid, flexible, or telescopic. One rapier feeds the weft halfway through the sheds of warp yarns to the arm on the other side, which reaches in and carries it across the rest of the way. Water jet loom. In water jet loom, a water jet is propelled across the shed with the force that takes the filling yarn to the other side. In it, a pre-measured length of weft yarn is carried across the loom by a jet of water. These looms are very fast with speeds up to 600 ppm and very low noise. Air jet looms. In air jet loom, a jet of air is projected across the shed with the force that takes the filling yarn to the other side, i.e. a jet of air is used to propel the weft yarn through the shed at speeds of up to 600 ppm. Uniform weft yarns are needed to make fabrics on this loom.